Hello everyone, welcome back into today's lesson video. Today we are going to be discussing Newton's law, Newton's second law, calculations. It's the simplest one. I don't think we're gonna even take more than 5 minutes. It's going to be very quick lesson, okay? This whereby we're going to be dealing with calculating our acceleration, whereby our force is given and the mass of an object moving in a surface that has a present of a friction. Okay, so we're going to be dealing with the friction and acceleration for the day, showing you how to calculate it and so on, so that you can move complex and complex. Okay, yes, please don't forget to subscribe to the channel. Please just click that red subscribe button. Please don't forget to subscribe, guys, so that the community can grow. Thank you so much. Let's get into the topic. Okay, guys, we have this diagram here. We are given that the 50 kg block is being pulled, or the force applied is 100 newtons into the right hand side or into the east. The surface is quite rough, okay, and the roughness of the surface, which is our coefficient of the kinetic frictional force, is equal to 0.13. As you can see, the coefficient of the kinetic frictional force is equal to 0.13. Okay, so the very first question here says draw a free body diagram. Okay, yes, let's jump into our answers without wasting no time. Answers. Okay, so let's draw the free body diagram for that 50 kg block. Okay, so mind you again, guys, your dot must be quite big. Okay, yes, in case two more forces go into the same direction. Okay, so you know that you can see that the block, it's on the surface, meaning that there is a normal force acting on it, okay, perpendicular from the ground. This is the normal force. You know that also, if ever there is normal force, there's the gravitational force. Okay, yes, and magnitude of the gravitational force, and the normal force are equal. Okay, this is our gravitational force. I'm so sorry about this, guys. So we have the applied force. This is the force applied. This is the force applied, and you have that your coefficient of the kinetic frictional force, meaning that the ground has a presence of friction. Okay, meaning that there is a frictional force there. Okay, yes, and I think you can see that the arms or the vectors that are showing the forces, the applied force and the frictional force, the one for the applied force is longer than the one of the frictional force, meaning that this shows that the applied force, the magnitude of the applied force is quite bigger than the magnitude of the frictional force. Okay, yes, so that's how it goes. So just for you to write each and every name of the force. Okay, I'm just going to write it here, but this is the free body diagram. I'm just extending it so that you can understand. This is the normal force. This is the normal force. This is the gravitational force. Gravitational force. Gravitational force, and this. Okay, and this is the applied force. This is the applied force, which is called 100 newtons. Applied force. And this is the frictional force. Okay, yes, it depends what kind of frictional force. It can be kinetic frictional force or static frictional force, but in this equation, it is kinetic frictional force because the object is moving. Okay, so we can say, okay, let's say frictional force. frictional force. And lastly, we have, oh yeah, that's how it goes. That's how it goes. I've mentioned each and every name of these kind of forces, but there's no need for you to write the names of the, when answering into your question paper, there's no, or into your tests, or whatever the case may be, there's no need for you to write the full name of the forces and represent like this. I'm just doing for you guys, okay, so that you can understand, okay, because some of you might be behind, okay. Yes, so right, okay, normal force is there, frictional force, ground is there's friction, as you can see. The gravitational force acting on the block, it's on the ground, and the applied force, as you can see, 100 newtons. Okay, that's how it goes. So your free body diagram may be out of 4 marks or 5 marks or 6 even. Okay, so it's quite a lot of marks, guys. So please train yourselves on how to write or draw free body diagrams. And mind you, free body diagram is different from a force diagram. A force diagram, this is whereby you're going to write or draw your box, 50 kg block, and show all the forces acting just like this. But the difference is that a free body diagram, it's represented by a dot, and a force diagram, this is whereby you're going to draw a box. Okay, so let's move to number 2. Number 2 says calculate the friction. Okay, so our number 2 says calculate the friction. Okay, so you know that this is the formula for the friction. Okay, you know that we're calculating the kinetic frictional force. Okay, so this is your mu multiplied by normal force. Okay, yes, this is equals to what's your mu? The roughness of the surface or the friction that is there, it's 0.13. Okay, 0.13 multiply, okay, by our normal force. How to get our normal force? Okay, and this is how we have to get our normal force. You know that for your horizontal forces, okay, the F net is equals to 0, because you can see that it's not moving horizontally, they are in balance. Okay, yes, your forces are at balance or at equilibrium. So it's normal force plus minus gravitational force. Gravitational force is opposing the normal force, moving downwards, equals to 0, and this becomes N minus Fg. So sorry for writing a small letter. Fg is equals to 0, so our normal force is equals to Fg. Okay, yes, that's why we have 0. So this becomes your normal force is equals to Fg is equals to mg, mass times gravity. And this becomes what's your mg? Your mass is 50. This becomes 50 multiplied by 9.8 by the gravity. Okay, and this becomes 50 multiplied by 9.8. Press on the calculators, guys. 50 multiplied by 9.8, and this gives us 490 newtons. Okay, this gives us 490 newtons. That's how it goes. So that's it, that's how it goes. So we put our 490 here because our 490 is our normal force. Okay, yes, therefore your normal force is equals to 490 newtons moving upwards, and your gravitational force is negative 490 newtons. Okay, yes, because it's moving downwards, opposing the motion of the normal force. Okay, so 0.13 multiplied by 490 multiply by 0.13, and that's equals to 63.7. 63.7, and that's our answer for the kinetic frictional force. So our kinetic frictional force is 63.7 newtons. So sorry, don't forget the units, guys. Always don't forget the units, because you are going to be penalized. Okay, yes. Okay, so that's how it goes for the frictional force. So we calculated the frictional force. So now we are moving to the acceleration. Okay, number 3. which says calculate the acceleration. With number 3, it says calculate the acceleration. So the acceleration, okay, so in order for you guys to calculate the acceleration, you have to make sure you consider all the forces acting on an object, whether moving horizontal or vertical, meaning that you should consider in this situation that, okay, my system or my object is moving horizontally, so I have to consider the forces that are acting horizontal for me to determine the acceleration. So let's say F net is equals to mass multiplied by acceleration. So this becomes, what are your net forces acting on that object? Okay, there's applied force, your Fa, minus your frictional force opposing the motion, the kinetic frictional force. This is equals to the mass, it's 50 multiplied by A. So this becomes 100 minus your friction. Your frictional force 63.7 is equal to 50A. Therefore 100 minus 63.7, so 100 minus 63.7, that gives us 36.6. okay, that gives us 36.6 is equals to 50A over 50 over 50. Let's cancel this, and our A is equals to, therefore A is equals to 36.6 divided by 50. Let's say divide by 50, and that gives us 0.73. okay, 0.73 meters per second. 0.73 meters per second. And that's how it goes. That's how it goes, guys. Yes, that's our answer, 0.73 meters per second. Yes, so that's how it goes, guys. Thank you so much. Please don't forget to subscribe. Guys. Have a very great day. See you next time. Cheers.